Welcome back. We're about to put to rest the whole slope formula idea for a while. We'll be using slope forever. But for right now, this is the last little bit of practice we get before we go a little further and talk about how to get lines from slope or how to graph lines using slope. And it's really important. So next few videos, very awesome, very cool. And we're going to kind of build off this idea. So right now, though, is just using the slope formula without a graph. Last video, I gave you a graph of a line. And we were pretty easily able to climb or fall and go to the right and figure out the rise over the run and therefore figure out the slope. Then I showed you that if I gave you the 2 points that on the line, that you can do the same thing algebraically. And that's what we're going to do. We're going to find the slope between any 2 points and therefore the slope of a line without having the line itself, just by using the math. Then we're going to graph the line, and we're going to very quickly and check out that the slope actually means the same thing. So I'm trying to build a connection. That's what I'm doing. So this is going to be a fairly quick video. We're basically just going to be practicing the last video without lines. So I'm not going to reteach you the slope. I'm just going to show you how to do it quickly, how to do it efficiently, basically. So we got 2 points on all 4 of these situations. It does not matter. I'm asked it all the time. Does it matter the order in which you call these points? No, it doesn't. I'm going to call this one x1, y1, and this one x2, y2, and then I'm going to call this one x2, y2, and this one x1, y1, just so you can see. It doesn't matter. I would tell you, do it backwards. Who cares? It does not matter. What matters is that when we're doing the slope formula, that your 1's go together and that your 2's go together. That's what matters. And then when you're plugging in those numbers, I'm serious about this. Create some blank spaces, use parentheses with minuses between them. It's so easy to make sign errors. It's not worth it. Slope's not hard. You can subtract, you can do slope. But it's easy to make mistakes. There's a difference there. Things that aren't hard and easy to make mistakes are 2 different things. So this is not a hard concept, but it's easy to make mistakes. So let's create a fraction out of this. I'm going to put parentheses here. I'm going to put parentheses on the denominator. I'm going to put minuses. Why the minuses? Why? Why do we subtract? Why? Why isn't it ever plus between them? Well, if you think about rise and run, we're finding the difference, the distance. So the difference between numbers. That's always a subtraction concept to start with. Yeah, we're going to get pluses if we subtract negatives, but it always starts out with minuses. So one thing I told you last time also is you can follow the formula straight up. Just plug in the numbers, man. You'll get it. And I usually give students the formula. But there's also an easy way to do it. Take your x2, y2. Just create this point in that relationship. So your y's naturally have to go in the numerator. That's your rise. It deals only with y's. Your x's have to deal with the denominator. That deals with your run, only your x's. But this point, if you cock your head a little bit, 3, 4, that is that point 3, 4. That's how that should look. That's a good way to check your work. y2 minus y1, here it is. x2 minus x1, here it is with the minus and the negative. I'm not screwing signs up. I'm not doing it in my head. And that point is that point. Kind of nice. Now, do the math slowly. Don't make mistakes in your signs, and then simplify your fractions if you have to. Here we get 2 over 4. Positive 2, positive 4. If you simplify, we get 1/2. Now let's plot this. Let's plot these points. Let's graph the line. Let's make sure that our slope is 1/2. But before you do that, how's that line look? Is this going to be climbing or falling? Look at your slope. Is it positive or negative? Is the line going to be climbing or falling? Climbing like super crazy or climbing like just barely at all? What's it doing? Ask yourself that before you graph it. That's got a rise of 1, a run of 2. Should be going up and over 2. Up 1, over 2. So it's climbing, but not like super crazy. Just kind of I won't say average. There's no average with slopes, but it's not climbing super fast. Not climbing super slow, but it's not radical. So let's plot this. Negative 1, 2, 3, 4, up 1, over 2, up 1, over 2. That's exactly what I'm trying to get you to see here. Well, we're going to do the next one, the next three pretty quickly. I would encourage you to just stop right now. Stop the video, pause the video if you have to. Work through the slope, graph the line. Work through the slope, graph the line. Work through the slope, graph the line. See that you're getting the same thing. I'm going to do them pretty quick. So first thing, I'm identifying one of these points as x1, y1, the other one as x2, y2. It does not matter what order these are in at all. What does matter is that you maintain the order for your formula, which means that if you start with one point here, you have to start with the same point here. That's why I'm telling you that if you look at it this way, it should create the point back. And then we're going to use a different point, 1, 2. So let's look at it this way. I've got the point, now I do my subtraction. So our slope would give us 3 minus 1 is 2. Negative 2 minus 2 is negative 4. I'm getting a slope of negative 1/2 here. Our slope's negative. It should be falling. Actually falling at the same rate that one's climbing. That's kind of cool. Let's plot the points. Negative 2, 3. And then we have 2, 1. Down 1 over 2. Down 1 over 2. Exactly the same idea for our slope. Last couple that we have, label this any way that you want. You should be getting to this point that it really doesn't matter. It doesn't matter which order you label it, as long as your 1s are together and your 2s are together. Then we start plugging in some points. Make sure that one point goes here, x comma y. The other point goes here, x comma y. So we'll start with this one. Sorry. So I'm going to double check because I almost made a mistake there. This is my point 4, negative 3. This is my point 4, 1. So I want to always double check to not make those mistakes. If we subtract negative 3 minus 1, that's negative 4. Oh, 4 minus 4 is 0. Huh. Tell me something. Is that defined? Is that undefined? Or is that 0? What's that tell you about the line? Diagonal line? Climbing? Falling, horizontal, or vertical. There's only 4 situations. We either climb, we fall, we're horizontal, or we're vertical. What's the undefined slope? Think about it. Don't wait for me. Think about it. Well, this has to be, this is like eating, trying to get 4 slices out of 0 pizza. This is undefined. What that means is that our line better be vertical. We're going to plot it. 4, 1, 4, negative 3, says that we have no run. We have 0 run. That's exactly what we said, and that gives us an undefined slope. Is it making sense to you? Are you okay that order of the points doesn't matter? What does matter is that you keep the relationship starting with 1 point for your numerator, start with the same point for your denominator. Make sure your signs are there. You always start with minuses between your numbers, between your coordinates, always minuses. If you're subtracting a negative, then yes, that's what changes to plus. But because we're looking for distances, we're considering differences. We're subtracting. When you get to a number over 0, you have something undefined. It means you have to have a vertical line. The last one. Let's label some points. It does not matter what order. What does matter is if I'm going to start with this point, I'm starting with the same point for my denominator. If I'm going to end with this point, I'm going to end with the same point for my denominator. You can always check your work. Just look at it sideways. I have both of my points there, minuses between them. I'm going to go slowly on the math here in my head so I don't make a mistake. I'm thinking, okay, negative 2 minus negative 2. I owe someone $2. I take away the debt of $2. I'm back to normal. I'm back to 0. On the denominator, I have $2. Someone pays my debt, takes away a debt of $2. Essentially, I get $4. Is that one okay? Can you have 0 over 4? Yeah, that's fine. That's the case in the last video where I said, well, you have 4 slices, you eat 0. You're on a diet. Get no pizza. What line is that? Is it climbing? Is it falling? Is it vertical? Is it horizontal? That says that you have no rise, but you are running to the right. That's a horizontal line. And when we plot that, That's exactly what we get. So at this point, before we go on into the equations of lines and graphing lines from a point and a slope, it's a huge deal for us. It's a big deal. We're going to get into like another version of 5-second graphing. I want you to be very good at finding the slope, whether I give you 2 points without a line or 2 points with a line. This is the same stuff. I need you to see that the slope we get from our algebra is the same as the slope we get from our line. We can create a line using our slope or with 2 points, or a point and a slope. That's kind of cool. So algebra gives us the same slope as our graph. Algebra, same slope as our graph. Algebra, same slope as our graph. If you get that, that is awesome. Go to the next video, and we're going to use the slope and a point to graph our lines. You see, when we go from here, and I told you we could go up 1 over 2, up 1 over 2, we can move from point to point all the time. What happens if you had 1 point, not 2 points, 1 point, and I gave you the slope, or you were able to find it? You could go from this starting spot, go up 1, rise of 1, over 2, run of 2, up 1, right. You can keep going from point to point and graph an entire line that way. That's awesome. We'll discuss that in the next video. Hope you guys are having a great day.